What if I told you there was a technology that could completely change how we get energy and resources from deep inside our own planet? Well, today we're diving into something that promises to do just that. And this isn't some small improvement, it's a total game changer, cooked up from a super clever mix of physics we already know. So let's just jump right into the big question here. How in the world do you drill through solid granite, one of the toughest rocks out there, not just a bit faster, but a whopping 16 times faster? And get this, how do you do it using 6 times less power than we do now? It sounds impossible, right? But the answer is actually pretty brilliant.
All right, to really get your head around how big a deal this is, you've got to see the numbers. And fair warning, they are absolutely mind-blowing.
I mean, just look at this chart. It kind of says it all, doesn't it? On the left, you've got your standard mechanical drill, just plugging away at about 2 meters an hour in solid granite. But on the right, that's the trifecta drill. And a full physics simulation shows it clocking in at 32.5 meters per hour. That's not a small jump. That's over 16 times faster. And hold on, because the speed is just the start of it. The total power needed plummets from thousands of watts down to just 850. The cost to build one of these things, it drops from as much as $500,000 for a rig to around $5,000 for a prototype. And the operating cost, this is the real kicker. It goes from $55 a meter to about $0.015. That is almost 4,000 times cheaper to run. It's just insane. So you're probably thinking, what kind of futuristic, magical technology is pulling off these crazy numbers? Well, this is where it gets really, really clever. It's not some brand new invention. It's actually 3 pretty simple tools all working together in perfect harmony. So here's our trio. First up, you've got acoustic waves, basically from a bunch of ultrasonic transducers, kind of like what's in an ultrasonic cleaner. Then there's a low-power blue laser, and get this, it's just 5 watts on average. That's less power than some flashlights. And finally, a small plasma torch, running on a tiny 85 watts. You see, on their own, none of these things could even dream of drilling through granite. I mean, you can't just point a 5-watt laser at a rock and expect anything to happen. The real magic, the whole secret, isn't in the tools themselves. It's all about how they interact. So, how does this all fit together? The entire secret to the trifecta drill, the whole idea, boils down to one simple, powerful word: synergy. You know, it's that classic idea where 1 + 1 + 1 doesn't equal 3. Here, it equals something like 100. Each tool in the system doesn't just add its own little bit of effort. It makes the next tool in line wildly more effective. Okay, here's the first handoff. Those acoustic waves are vibrating the rock like crazy, creating this huge network of tiny microscopic cracks. Now, this weakens the rock, sure, but the really important part is that it makes the surface rough. A smooth bit of granite is actually pretty reflective, but this newly roughed up surface acts like a sponge for light, letting that little laser dump 3 times more energy straight into the rock. And that leads us to the second handoff. That now super effective 5-watt laser heats up a tiny spot to over 1,000 degrees Celsius. And this preheating step, it's the secret sauce. See, hot granite is way better at conducting electricity than cold granite. So when the plasma torch hits that spot, its energy transfer efficiency just goes through the roof, from a pretty mediocre 40% all the way up to an incredible 92%. So you see what's happening here, right? We're not just adding things up. This is multiplication. The 3x boost for the laser gets multiplied by the massive boost for the plasma. Each stage creates the perfect setup for the next one, and you get this huge cascade of efficiency. It's a chain reaction of pure performance. Okay, this all sounds amazing on paper, but the folks behind this didn't just stop at the theory. No, they built a complete multi-physics simulation to prove that this whole dance actually works exactly like they thought it would. But let's be real, the crucial question is, can a computer model truly capture this incredibly complex interaction between sound, light, and plasma? Well, according to the creators, the answer is a big, loud yes. Okay, check this out. This slide is showing you the actual output from the simulation over just a couple of seconds. Look at the top left. You see the temperature just climbing and climbing as the laser does its thing. Then, bam, right at that orange dotted line, the plasma kicks in. And then look at the graph on the top right. The drilling depth just takes a nosedive. It's drilling at an incredible speed. It's a perfect picture of the theory in action. So what were the final validated results from that simulation? Well, they line up perfectly with all the wild claims. A drilling rate of 32.5 meters an hour,
a 16.2 times speedup, and it's 6 times more power efficient. The whole system has an efficiency of 2.2%, which might sound low, but believe me, in the world of drilling, that is astronomically high.
So a drill that's 16 times faster, that's not just a neat piece of engineering. This is the kind of thing that has the potential to help solve some of the biggest challenges we face as a species. Just think about geothermal energy for a second. It's clean, it's reliable, it runs 24/7, so why don't we have it everywhere? Well, because it costs a fortune and takes forever to drill deep enough. A typical well can take 4 months and cost a cool $15 million. With the Trifecta drill, that could potentially drop to less than 3 weeks and cost just $2.5 million. It could make clean energy affordable and accessible for everyone. And it's not just geothermal. We're talking about making mining safer and more efficient, letting scientists drill deeper into the earth than ever before. When you add it all up, you're looking at a potential market of nearly $1 trillion. This is huge. But you know what might be the most revolutionary part of this whole project? It has nothing to do with the tech itself. It's about what the creators decided to do with it. Yep, you heard that right. All of it. The whole shebang. Every single line of code from the simulation, every hardware plan, all the physics behind it, it's all available for free, for anyone to use. There are no patents, no corporate secrets, nothing is hidden. They give you a complete parts list to build your own prototype for about $5,000. There are step-by-step assembly guides, files for 3D printed parts. They're basically handing you the keys to the kingdom. The only barrier to entry here isn't a legal wall, it's just your own curiosity and a willingness to build. And the philosophy driving this is just, it's incredible. As the creators themselves say, a technology this transformative, one that could unlock clean energy for billions of people, shouldn't be locked up. It should belong to humanity. So this leaves us in a really fascinating spot. The theory is solid, the super complex physics simulation checks out, the parts are all out there ready to be bought, the instructions are written, everything is ready to turn this digital proof into a physical reality. The only thing missing is someone to actually build it. And that leaves us with one final, very important question.